Welcome back to another video, and in this particular video we're going to go over how do we perform a hypothesis test for the population proportion of one sample. Okay, so we're going to kick things off by, as always, going over the conditions necessary for a hypothesis test for the population proportions. Well, please go back and watch the introduction to hypothesis testing video if you haven't seen that. But as we mentioned, anytime we do any type of sampling, we have to satisfy the central limit theorem. Specifically for us, we're going to have to satisfy the central limit theorem for proportions, right? And what are those? These should be very familiar to you all by now, but we have an independence assumption. And the way that we check that is we look for, is there any type of randomization? Did we collect this using random sampling? And did we sample less than 10% of the population? If those are assumed to be correct, then we can say that we have an independence assumption successfully met. And then for proportions, we have to make sure that our sample size that we collected is large enough. And how do we do that? We do that via the success and failure condition. And so what we do is we take in our sample size and we multiply it by this new symbol P sub 0. That is, I'll call that P naught. What that is that is the proportion that's located in your hypothesis. We call that the hypothesized proportion, okay? And we'll go over these in a second. So we need n times our hypothesized proportion to be bigger than 10, and we need n times 1 minus that hypothesized proportion to be bigger than 10, okay? So if all these conditions are satisfied, then we can do the one proportion hypothesis test. Okay, so here are the steps on how to perform that hypothesis test for proportions. First thing we just went over is you want to check your conditions. All right, you want to check for randomization. You want to check for less than 10% sample. That'll get you your independence assumption. And then you want to check your successes and failure condition. N times P naught needs to be greater than 0. N times 1 minus P naught needs to be greater than 0. Your next step, if your conditions are met, go ahead and start writing your hypotheses. Once again, go back to the introduction to hypothesis testing video. You'll know that we have two types of hypotheses. The null hypothesis will always have an equals to sign. So we're always saying that, hey, the population proportion is unchanged. Okay? But then your alternative hypothesis can take one of three different possibilities. Either it's going to be a greater than, a less than, or a not equals to. Well, it depends on the scenario that you're in. And we'll go through a couple examples and you'll see how these scenarios are worked out. So once we have our hypotheses written, okay, we then calculate a test statistic. And so a test statistic, basically it just takes our p hat. So let's write that down. P hat is our sample proportion. And what it does is basically it standardizes the sample proportion in terms of that null hypothesis value. Because remember, P naught comes from the hypothesis. And so to calculate P hat, oh, I already have the formula right here. So to calculate P hat, you just simply do X divided by N. Remember, it's the number of successes divided by the sample size. And so once we have P hat calculated, we then go and use the test statistic formula, okay? And it's going to be P hat minus the P naught over the square root of P naught times 1 minus P naught over N, okay? Once again, that formula, that square root in the bottom should look familiar. That is the standard deviation from the central limit theorem that we calculated. Okay, once we have this test statistic, we go ahead and calculate the p-value. And then we make a comparison. We say if the p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we fail to reject the null hypothesis. And then your last step is kind of state like a conclusion / interpretation. Meaning if you ever reject the null hypothesis, that means that there is significant evidence to say that the alternative hypothesis is correct. If you fail to reject the null hypothesis, there is not significant evidence to say that the alternative hypothesis is correct. Once again, I'm begging you guys, go back and check out that intro to hypothesis testing video for more information on what these individual steps are doing. All right, with that in the background, let's go ahead and let's get into an example. Okay. So I'll go ahead and spoiler alert, I'm going to do this by hand. first of all, and then I'm going to show you how to do this using some technology. All right, so just hang tight. Okay, for example, the two major college entrance exams that a majority of colleges accept for admissions are the SAT and the ACT. The ACT looked at historical records and established 22 as the minimum ACT math score for a student to be considered prepared for college math. An official with the Illinois State Department of Education wonders whether less than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 records of students who have taken the ACT and finds that 219 are prepared for college math, aka they got higher than a 22 on that test. Does this represent significant evidence that less than half of Illinois students are prepared for college mathematics? Use the alpha equals 0.05 level of significance. All right, folks. First order of business is we need to check our conditions. Okay? So, what's that first condition? Independence. And the way we check that is through randomness. And did we sample less than 10%? All right, well, the random question, that's pretty easy to answer. It says that she obtains a simple random sample of 500 students. So did we conduct random sampling? Yes, we did. Let's see. She's working with the state of Illinois, and we only asked 500 students. So certainly 500 students are way less than the total number of possible students taking the ACT. So therefore, less than 10% was sampled. So yes, we can say we have done our independence. Okay? All right, next. Okay, next here. We need to check the success and failure condition. Okay? So in order to do that, I'm going a little bit out of order here. In order to do that, let's write our hypotheses. Okay? So that actually should have been my first step here. Write the hypothesis. So the hypothesis is this. We are trying to test if there is significant evidence that less than half of students are prepared for college mathematics. So what that means, and I'm jumping down a little bit here to part B, guys, is that we're going to have two hypotheses, the null hypothesis and the alternative hypothesis. We are testing population proportions, so that's where we get P from. In a later video, when we go over population means, we're going to have the Greek letter mu there. We're trying to see if the proportion is significantly less than half. Well, what's half? Half is 50%, right? So that means that our null hypothesis, null always has an equal to, and it's going to be 0.50. That's what it means by half. And then the alternative means less than half, so that's why it's a less than 0.50. So that's our hypotheses. And so what that means is that P null, the hypothesized proportion, is 0.50. So the P naught that we're going to use in all of our formulas comes from your hypothesis, and it's going to be that 0.50 right there. Okay? All right. So success and failure. Remember, success and failure, what success and failure condition was, we have to check N times P null. Well, that's going to be N times, well, let's do it this way. N times P null. Well, that's going to be N, so what's our sample size? We got a sample of 500 students. So it's going to be 500 times P naught, which we already said was a 0.50. Okay? Now I don't need a calculator for that. I know that's 250, and I know that's certainly bigger than 10. So that means we have 250 successes based off of that P naught condition. And then we do N times 1 minus P naught. So that'll be 500 times 1 minus 0.50. So 1 minus 0.50 is still 0.50 times 500. That also gives us 250. So that's greater than 10. So are all the conditions met? You betcha. Okay? All right. Calculating the test statistic. All right. So the test statistic has this formula. So it's going to be Z test, right? Because we have now a normal condition due to the central limit theorem. The z-test is, I'm just going to rewrite the formula, it's p hat minus p naught over, over the square root of p naught times 1 minus p naught over n. Okay, so once again, I just grabbed that formula from right here. Okay? All right, so we have p naught. We know p naught is 0.50. What is p hat? Remember, p hat is the sample proportion. Okay, this is where our data comes into play. So p hat is going to be x over n, the number of students that were prepared over the total number of students. Well, they told us there were 219 that scored higher than a 22 out of the 500. So we're going to do 219 over 500. And let's go to our calculator here. I'm going to do 219 divided by 500. And let's go 3 decimal places. That's a 0.438. So that is our sample proportion. Once again, that should be familiar as well. We've done that before. All right, now we have all the information we need to calculate z-test. So z-test will be our p hat of 0.438 minus our p naught, right, that we got from the hypothesis of 0.50, divided by this standard deviation, which is the square root of 0.438 times 1 minus 0.438 over n, which is our sample size of 500. Okay? Let's get this z-score to 3 decimal places, let's say. Okay, for that, we definitely need a calculator. So, in my calculator, clear it out. I'm going to do open parentheses, 0.438, okay, minus 0.50, close parentheses, divided by, and I'm going to open up another set of parentheses here, the square root of, it was 0.438, still underneath my square root, do an open parentheses for multiplying, 1 minus 0.438, close parentheses, still under the square root, divide by 500. Now we can close our parentheses and calculate. And there we go. To 3 decimal places, we get a negative 2.794. So that is our test statistic. Okay, moving along. So now that we have our test statistic of a negative 2.794, let's go ahead and calculate the p-value. So what would the p-value be? Well, once again, go back to our intro to hypothesis testing video, and you know that now we have a normal distribution of z-scores, right? And in fact, we know for that z distribution, right down the middle is where z is equal to 0, we're going to now plot our test statistic of a negative 2.794. Okay, we're going to plot that over here somewhere. Negative 2.794. And the question now becomes, and this is our test statistic, and the question now becomes, where do we shade, to the left or to the right? Well, we go to the alternative hypothesis. And this is a left-tailed test, meaning we shade to the left. How do we know? Just look at the inequality. So we shade to the left. If it's a less than, you shade to the left. If it's a greater than, you shade to the right. If it's a not equals to, we call that a two-tailed situation, where you have both a positive and negative test statistic and you shade in both tails. But for us, simple one left-tailed test, this area, which we'll calculate in a second, is the p-value. Okay. So how do we calculate it? Well, we're going to use some technology. We're going to go to StatCrunch and we're going to use the normal calculator there. All right, so here we go. Okay. Grab the mouse here. All right, so to get our normal calculator, you guys know what to do. Stat, we go to calculators, we go to normal. Drag this over, make this a little bigger for you guys. All right. Since we are now converting everything over to the z distribution, we know that the mean is still 0, and the standard deviation is 1. Okay, that's just a rule for z distributions. However, our z-score was a what is that? Our z-score was a negative 2.794. Okay, remember that was our z-score. So now we click on compute, and to 3 decimal places, even to show us a picture, to 3 decimal places, our p-value, our probability, is a 0.002. So our p-value, let's get that going. All right, our p-value was a 0.002, so a really small p-value. All right. So now we need to make a decision. And this is how you make a decision. You compare your p-value to your alpha, your level of significance. And so they told us earlier in the problem, they told us alpha was a 0.05. They gave us that value already. So we're going to take a 0.002 and we're going to compare it to alpha, a 0.05. So the question becomes, when you have a 0.002, how does that compare to 0.05? Well, what I'd like to do to make it even easier of a comparison, we can add as many zeros as we want to the end of a number. It doesn't change what that value is, or at least a decimal, excuse me. So a 0.002 is, we can compare that to, instead of a 0.05, we compare it to a 0.050, which means now we're comparing 2 to 50. Well, certainly 2 is less than 50. So we are in the case where our p-value is less than alpha. Well, if you don't mind me scrolling back up, what do we say whenever p-value is less than alpha? If the p-value is less than alpha, we should reject the null hypothesis. So that's exactly what our decision is going to be. So our decision is that we are going to reject the null hypothesis. Okay? All right, so what does it mean to reject the null hypothesis? It means that there is enough evidence, or there is sufficient evidence to support the claim that, okay, so what we're testing. So let's go back here. Remember our null hypothesis was p is equal to 0.50, and the alternative was that p is less than 50? What we're saying is that we now believe that we're rejecting H null, and we're saying that HA is the correct hypothesis. So we have enough evidence to support the claim that, yeah, the proportion is less than 50%. That the proportion of students prepared for college math is less than 50%. Okay? Once again, because we rejected null hypothesis, we're saying that the HA is true. All right? Okay, so before we go to the next example, let me show you quickly how we can do this in StatCrunch. So let me tell you this, folks. Technology is wonderful, it's great, but it can only help us so much. What I mean by that is that the calculator, or StatCrunch, will help us get the p-value in our test statistic very quickly, but it's still up to us to write the correct hypotheses, and it's up to us to make the right decision and the right interpretation. Okay? But as far as how will we quickly get at that statistic, that test statistic, and the p-value, let me show you how we do that. So keep in mind that our HA is a less than, and our p hat was found by taking 219 over 500. Those numbers are going to come into play in just a second. So here we go. Let's get out of this. So to do a hypothesis test for proportions, we go to stat. We go to proportion stats. And we are in the one sample case, and we are with summary. We have the summary data. Okay. All right. This should look very familiar. We did the same thing with the confidence intervals for proportions, right? We need the number of successes. How many successes did we have? How many students were prepared? It was 219. Out of 500 total students. Okay? But now this time what's different than confidence intervals is that we are performing a hypothesis test. So we're going to select the hypothesis test option. And notice already they're telling us that the null hypothesis isn't equals to, right? Because we know that. Null hypothesis always equals to. Now we need to put in the hypothesized proportion. So we are testing if our hypothesis includes a value of 0.50. So that's why, that's why if it's not already in there, we should type in a 0.50. Okay? So that's the null hypothesis. The alternative hypothesis, very important, folks. We have to select the correct type of test we need to do. What I mean by that is, are we shading to the left? Or I guess it starts with a not equals to. So are we shading two tails? Are we shading just a left tail, or are we shading a right tail? In our case, we are doing the left tail. We're trying to see if the proportion is less than. Okay? All right, with all that being said, let's go down here to compute. That's all it takes, folks. Slide this over for your convenience. And look at that. Okay? So what we have here is our results. So notice our test statistic, right, is a negative 2.77. Ours, when we did it by hand, was a negative 2.79. Differences are because of rounding. All right, and then notice that our p-value is very similar to what we got. It's a 0.003 if you round it using their technology, but we got a 0.002. So as you can see, it was very, very quick and straightforward to get the relevant statistics from StatCrunch. So I highly recommend that you guys use this. But hopefully that shows you how we can use StatCrunch to perform a hypothesis test for one proportion. Okay. If you allow me, let me do one last example. We're going to do this all in using technology to speed this up. So the U.S. Census Bureau tracks trends in minority ownership of businesses. A random sample of 1,800 Michigan businesses showed that 6.2% were minority owned. Test the claim that the proportion of minority owned businesses in Michigan is statistically different from 7% as one newspaper claims. We're going to use that alpha, that level of significance of 5% again. Okay? All right, so once again, we don't list out the steps here, but let's go through all of our steps. Let's check the conditions. Okay? So checking conditions, let's talk about the independence assumption. To do that, we check randomness, and we check less than 10% sampled. Okay? Well, let's see here. A random sample of 1,800 Michigan businesses. So we have random sampling. Less than 10% sampled. Well, yeah, we sampled 1,800 businesses, but we're talking about the entire state of Michigan that we're looking at. There's certainly a lot more than 1,800 Michigan businesses, so yeah, I think we can safely assume that we have sampled less than 10%. Therefore, the independence assumption has been satisfied. Okay? Also, we need to check the success and failure condition. Okay? Well, to do that, we need to check n times p naught. And we need to check n times 1 minus p naught. Well, to get p naught, we need to write some hypotheses. So what are we testing here? We're testing if the proportion, hope you guys can see that, the proportion is different from 7%. So we'll come back to our success failure condition in a second, but the null hypothesis is that the proportion equals 7%. Always write your percents as a decimal, 0.07. And then the alternative hypothesis is that the proportion is different than the 7%. Well, how do we check different than 7%? That is a not equals to. So different or change means not equal to 0.07. So from this, we can see that our P naught, our hypothesized proportion, is 0.07, 7%. So what we need to do is we need to go back to our success and failure condition. We're going to take N, our sample size was 1,800. We're going to multiply it by 7%, 0.07. And we're going to get, I don't know, let's see what we get. Where's my calculator? Okay, here we go. 1,800 times 0.07, we get 126. And we also need to do 1,800 times 1 minus 0.07, which is definitely going to be more than 10, right? So 1,800 times 1 minus 0.07, 1,674. Okay, both of these are bigger than 10, so all the conditions are satisfied. All right, so next we have our hypotheses written. Now let's go ahead and calculate our p-value. Let's get our test statistic and our p-value. Test stat and p-value. Well, to do that, we're going to go to the calculator, but remember, guys, or the StatCrunch. Remember, StatCrunch needs X. StatCrunch needs the number of successes. So when we go in and we're going to put in 1,800 for N, but what's the number of successes? How many of that 1,800, right, actually were minority owned? So let's do this. So they told us already that the P hat is 6.2%. So let's write that down. So P hat is 0.062. That was a 6.2%, okay? That's the sample proportion. Well, to get the X, the number of successes in our sample, X is equal to, and we should know this, right? X is equal to N times P hat. Just like what we did up before with the success and failure condition, except for we used the hypothesized mean. This time we're just going to use the sample proportion. So X will be N times P hat. So that will be N is 1,800 times a 0.062. Let's see what that gets us. That gives us 111.6. Okay, so guys, what we typically do with these is that we typically represent successes as a whole number. And so what I always like to do is no matter what the number is, if it's a decimal, round up to the nearest whole number and make that 112. Okay? So that means that in our sample, out of 1,800 businesses, 112 of them were minority owned. So now we can go to StatCrunch. We have all the information we need. Okay? All right, so let's get the calculator going here. StatCrunch warmed up. All right, so we go to stat. We go to proportion stats. One sample with summary. Get out of the way. Okay, number of successes. Based off the information we just talked about, the number of successes is 112. 112. The number of observations was 1,800. And we're performing a hypothesis test. But this time, we're testing if the proportion equals, let's see, not 50%, but 7%, 0.07. So let's get this out of here. We're going to do 0.07. And then we are performing a two-tailed test. So out of our options, remember we're doing different. Different means not equals to. So if we go to compute, let's see if you guys can see that. Come here, mister. All right, there we go. So look right there, guys. Our sample proportion is the 0.062, just like we wanted. And the z-stat is a negative 1.293. Let's write that down. So our z-stat is a negative 1.293. And our p-value is a 0.1959. 0.1959. Okay? Now, let us make a decision. We are going to take that 0.1959, that is our p-value, and we compare it to alpha, which they told us to use 5%. I'm just going to add a couple zeros to make the comparison easier. This is alpha, our level of significance, and we can see that the p-value is greater than alpha. So what's our decision whenever the p-value is greater than alpha? We should fail to reject the null hypothesis. So what does that mean in terms of our interpretation here? It means that there is not enough evidence to suggest that the alternative hypothesis is true. So what was it saying? That the proportion was different than 7%? So there is not enough evidence to suggest the population proportion is different than 7%. Okay, so there's not enough evidence to say that the proportion of minority-owned businesses in Michigan differs from 7%. Okay, so what I hope you can see here, folks, are the two different ways we get the number of successes, the X, for the one proportional hypothesis test, and you're seeing how we can use technology to speed this up quite a bit. But once again, we still have to understand how we construct the hypotheses, and we have to understand how to make these decisions and conclusions. Alrighty, guys, I hope that kind of clears up a little bit hypothesis testing for proportions, and I'll see you in the next video.